This is a novel orally available small molecule, a proprietary small molecule from Satellos that acts as a regenerative medicine. So we often say we're in regenerative medicine, and people tend to think right out of the gate that means we're doing some sort of cell treatment. We're administering cells in some way. We're not. What we're doing is actually giving a drug, giving a small molecule that actually acts on the stem cells that are already inherently within the patient, um, and drives regeneration, in this case of muscle. And the way we came to this approach was Duchenne has always been known as a disease of the loss of dystrophin. But for many years, the other typically the other treatments that are out there now are approaching the loss of dystrophin in the muscle fiber. Dystrophin acts there as a structural protein. If you don't have dystrophin, your muscle certainly doesn't look as healthy. But what Michael Rudnicki, who's a professor from University of Ottawa, discovered, he's our scientific founder. He discovered that, in fact, there was another critical role of dystrophin in the muscle stem cell. So in a person, you have these stem cells that sit there on your muscle. They don't do much unless you need to regenerate muscle. And in all of us, you need to do that whenever you damage muscle. And what he discovered was without dystrophin in those stem cells are much less likely to be able to go through the necessary transition through what we call asymmetric division to create progenitors, which then create new muscle. So you need those stem cells to sort of wake up, create another type of cell called a progenitor, which can then go on to regenerate muscle. And what he discovered was without dystrophin, it's much less likely that stem cells can do that. And in fact, in Duchenne patients, one of the problems they have is an inability to as efficiently and effectively regenerate muscle as you would see in a healthy individual. And we think that's what explains that, Duchenne's not really a congenital disease. These kids are born and do fairly well. They grow, they put on muscle, they do fairly well for the first 5 or 6 years of their lives. And then what we believe is really happening is the regenerative capacity of their muscle cannot keep up with the damage that they're doing. And then what you see as muscle is literally lost under those circumstances. It's not maintained. What 3247 does, what SAT3247 does, is it resets those stem cells, if you like. We're not replacing dystrophin, to be absolutely clear. We're not putting dystrophin back there, which technically would be very challenging in a niche cell like a muscle stem cell. We're actually acting on the stem cell to sort of reinitiate the signaling process that's missing with the lack of dystrophin and allow the stem cell a much greater chance to be able to go through asymmetric division and regenerate muscle. We discovered the pathway, we discovered the target by a lot of screening that we did in our own labs, and it's a sort of a pathway to the side of dystrophin. Everybody wants to know, so how does that fit in with dystrophin? Well, it doesn't replace it, but it really replaces the signaling aspect of dystrophin. In the stem cell, dystrophin is not a structural protein, it's a signaling protein. And we replace that action with the action of our compound and allow the cells to divide and regenerate muscle. And preclinically, when we have administered this to animal models of Duchenne, both in mice and in a larger animal, in the dog, what we can show is that we can return muscle and improve function. Ultimately, the most important thing for these patients and what we've measured in a lot of our preclinical work is muscle force, because there's a rapid drop off in the force from muscle in Duchenne patients. We can increase the force of muscle, increase the output from muscle in these models, and it's simply an oral pill. I mean, this is as I say, a very different approach in terms of administration. It's not an injectable or anything like that. It's an orally administered pill. The way we think of it is an altogether different aspect of the disease. So when the disease was first looked at, I think this often happens in science. I think the first thing that struck everybody was the loss of dystrophin in the muscle fiber causes a problem for the muscle structurally. And that's definitely true. We are not sitting here at Satellos saying that is definitely an aspect of the disease. What we discovered, I think, was something that wasn't, you know, it took a while to discover. In fact, there was a lot of information out there in the literature of things that were happening in the Duchenne patients that people didn't really understand, that now we understand much better if you consider that there's a second problem, shall we say. And we think that second problem is probably more significant for the patient in terms of function for a number of different reasons than the first problem. But they are both issues for the patient. There's no doubt about that. And so we're approaching it from this different direction, saying without being able to get regeneration back to a better level of efficiency, you are always going to lose muscle. Regardless of whether there's dystrophin in the muscle fiber or not, you are going to continue to lose muscle. And we believe one of the differences with our treatment is that the treatments that actually replace dystrophin in the muscle fiber, the idea would be you would slow progression of the disease. We really believe with this approach of getting regeneration back that you could actually push back against the disease and gain function back, because in theory it will allow you to put muscle back where it's been lost, at least up to a certain point, right? I mean, once the disease progresses very, very far, that may be difficult, but at least up until a point, we should be able to replace muscle and regain function. The answer practically is that we are regenerating muscle which still doesn't have dystrophin in it from a structural point of view. Your comment is exactly accurate. The piece that is very interesting, though, is based on those very young Duchenne patients and also some data that's come from other labs out there around what are referred to as escaper patients. We know that function on muscle that doesn't have dystrophin is not perfect, but it's quite significant. So patients can walk on muscle that lacks dystrophin. We know that because the very young patients do that, right? They're born without dystrophin or with a very much lower level of dystrophin, depending on their mutation, and they walk initially up until a certain age. The other piece of information is this, what I refer to as escapers, and this people have found this both in patients and in the dog model, where if you have a second mutation and it looks as if that mutation is in the stem cell and allows you to continue to regenerate muscle in the absence of dystrophin, you have a much less severe form of the disease, shall I say, which includes walking. Some of these patients walk well into their 20s, maybe even into their early 30s. And they definitely have Duchenne. They definitely have no dystrophin, but it looks like, and a lot of this work is being done right now, so not all the pieces have been identified, but it looks like that second mutation is in the stem cell and in the machinery, which allows that stem cell to become more efficient. So it's almost a natural model of what we're trying to do with our small molecule. It's the same thing happening, we believe. If you maintain regeneration so the muscle doesn't disappear, the muscle without dystrophin, its structure is not perfect, but it's pretty good. It's pretty functional. It would allow patients, we believe, certainly to walk for longer, and presumably help with other muscle function, upper body function, and those sorts of things as well.